As you know, dy by dx means differentiation of y with respect to x. We also show it by y dash, sometimes by y1, and sometimes even by y dot. After getting differentiation once, you can differentiate once again. If you do that, then it is written as d2y by dx2. This is not square. It is also written as y double dash or y2 or y dot dot. You can differentiate third time also, fourth time also. Sometimes you may have several variables. Here x and y are the variables. So we study rate of change of one with respect to the other. But sometimes it is possible that you have several variables. If some rocket is traveling in space, then as time changes, its x position may change, y position may change, z position may also change. Sometimes you may have several variables. If you want to study rate of change of only one variable with respect to other, then in place of d, this sign is used. If I want to study change in x with time, I really am not concerned about y and z. In other words, I treat y and z as constants, even though they are variable. Because I am studying only change in x due to change in time, I treat y and z as non-variable, and now rate of change of x with respect to t is denoted by dou x by dou t, and not the usual way dx by dt. This is called partial differentiation, and when several variables are involved, partial differentiation can be used. You will come across it rarely. Partial differentiation. Now that we have talked about differentiation, we move on to integration. There is a private message about second derivative, significance of second derivative graphically. Significance of second derivative graphically. You see, just like y is a function, and you plot y versus x, you can find dy by dx and plot dy by dx with respect to x. And then for that graph, if you draw a tangent at a point, then slope of that tangent would tell you d2y by dx2. So d2y dx2 is nothing but the slope of the tangent when you plot dy by dx with respect to x. Any other question about differentiation, let me know, or I am moving on to integration. Integration is about opposite of differentiation. So if differentiation of x to the power n is this, then integration of this is x to the power n. How do we show it? We show it by this sign, but that sign alone is not enough. With respect to whom? Just like here we say d dx with respect to x. Here we say with respect to x. Like that. Whose integration we want, we put it here. Right, so that's the basic idea of integration to introduce it. But there is little problem here. Say for example, d dx of x square is 2x. That means integration of 2x would be x square, right? But d dx of x square plus 5 is also 2x, isn't it? Any problem about this? Let me know. That means integration of 2x from here is x square plus 5. Integration of 2x is x square. Integration of 2x is x square plus 5. That's a little problem. And why only 5? Put anything, any constant that comes to your mind. d dx of x square plus any constant will be 2x. That is why we call it indefinite integral. X square plus 5, x square plus 10, x square plus 1000. Answer can be anything. So what is integral 2x? We are not definite about the answer. It could be x square plus anything, any constant. Anything means any constant. X square plus any constant. Consider another example. Differentiation of sin x is cos x. But differentiation of sin x plus 100 is separate, not inside sin. that is also cos x. Any question about this, let me know. If this is not clear, let me know and I will explain. Okay, that has come from the formula. Differentiation of first function plus second function. Differentiation of first plus differentiation of second. What is differentiation of 100 alone? What is the differentiation of 100 alone? Constant, 0. Differentiation of constant is 0. 100 or any constant. So that's why you get cos x. Now when the question is what is the integral of cos x, then we are not definite about the answer. So what do we do in such case? We just write sin x plus some c. We don't know what c for sure is. C can be any arbitrary constant. So this type of integral is called indefinite integral. The good thing is that all the formulae that you have learned for differentiation, they work. So if I ask you what is the integral of e to the power x, you can perhaps tell, because you have learned that d dx of e to the power x is e to the power x. So integral of e to the power x would be e to the power x plus c. Right? So many standard results you can use. Many standard results of differentiation you can use in integration. So that's something good about it, making it easy to learn. Now, while this we have discussed for differentiation, and while this is also true that integral of this would be x to the power n plus some arbitrary constant, generally you would not find this as standard formula in integration textbooks or calculus textbooks. You will find this type of formula. Integral of x to the power n dx is equal to x to the power n plus 1 upon n plus 1 plus c. But even that is very easy to verify. Just differentiate this side and see if you are getting this differentiate this and see if you are getting this or not. Constant comes out of differentiation symbol. And then d dx of x to the power constant is that constant x to the power that constant minus 1. That will be x to the power n. So when differentiation of this thing is that thing, then integral of this thing would be this. So in integration standard results, you would find this result, x to the power n plus 1 upon n plus 1 plus c. Any questions if you have regarding this, let me know. Next, Standard result. Integral of cos x is sin x plus some arbitrary constant. I don't think there will be any problem with this. d dx of cos x is minus sin x. So, integral of minus sin x should be cos x plus c. While this is fine, in textbooks of calculus you would not find this in this format, but you would rather find integral of sin x formula. An integral of sin x is minus cos x plus c. So no problem, we will prove it. Consider the right hand side, differentiate it. Minus is a constant, minus is minus 1, which is a constant, comes out, and d dx of cos x is minus sin x. So you have sin x. If differentiation of this is that, then integration of this would be this. Of course, some arbitrary constant can always come. Any questions? Let me know. Fine. Next formula comes from 10x differentiation formula. So 10x differentiation formula is this, and therefore integral of sec square x would be 10x. There may be some arbitrary constant also. The next formula is for integral of cosec square x. How to prove it? Very simple. Differentiate the right hand side. See what you get. Minus coming out, and d dx of cot x, and that would be minus cosec square x. Done. So all of these we are able to get very quickly because we know the results for differentiation. Then how about this formula for integral? Integral sec x tan x is sec x plus c. Again very simple. Consider the right hand side. d dx of sec x is sec x tan x. So obviously its integral would be this plus some arbitrary constant. Now consider one more, integral of cosec x cot x, and the result for that is minus cosec x plus c. How to prove it? Consider the right hand side, derivative of right hand side, derivative of right hand side, minus will come out, and then we have d dx of cosec x, which is minus cosec x cot x. Minus minus would become plus, and the answer is cosec x into cot x. Now tell me, what is the formula for differentiation of log x? Just 1 by x. Fine. That means integral of 1 by x would be log x plus c. Another standard result. Now, these are some standard results. In differentiation, not only did we do some standard results, but also we did some theorems so that we could handle addition, subtraction, multiplication, division and chain rule. In integration also we have some theorems. The first one is that if you have integral of some constant times function, then that constant comes out. There was a small interruption. So when we have k times fx dx, then the constant comes out of the integral, just like when you have differentiation of k times fx, then constant comes out of the differentiation. Here also constant comes out of the differentiation. Very useful theorem, because now you can handle something like integral of 2x square. So you would just take this 2 out, and then you would use the formula for x to the power n. X to the power n would be x to the power n plus 1 upon n plus 1, and then some arbitrary constant. So this theorem is going to be very useful. Then addition. Just like in differentiation, addition, subtractions are very easy to handle. So is the case in integration. So when you have several functions added, subtracted, no problem. It's all very, very simple. Just like differentiation, you can isolate them from each other. So take first out, second out, third out. Whether plus sign or minus sign, just copy it. Whether plus sign or minus sign, just copy it. After you have integrated, at the end put an arbitrary constant c, and you are done. So addition, subtraction follows the similar procedure. Then for multiplication, there is a theorem, but it's somewhat difficult and often not required too much in physics. If at all it is required, I will introduce it at that point, but generally you won't need that multiplication formula in physics discussion. And for division there is no formula. So for division there is no formula, for multiplication there is, but that we won't discuss right now. And regarding chain rule type of thing, that means this type of situation, how will you handle? Integral of sine 2x type of thing. Again, don't just do this. Don't just do this. Integral sine x dx, if the formula is minus cos x plus t, then don't just do this. That's not correct. This will be correct if 2x is there everywhere in place of x. This will be true if 2x is there everywhere in place of x. Here also it should be 2x. If it is d of 2x, then this is correct. But if it is d of x and 2x here, 2x there, no, it's wrong. So the question now is then how to handle this type of situation. In case of integration, we don't call it chain rule. We don't call it chain rule. We call it method of substitution. We call it method of substitution. In differentiation also we put something equal to t or something equal to u. So it was substitution there also, but there you were able to get some chain. There you were able to get some chain. Here you don't get the chain. Here you handle it in a different way. So how do you handle it in integration? Let me illustrate by this case itself. Now we don't know the formula of sine 2x with respect to x. We do know the formula of sine 2x, sine of some variable with respect to the same variable. That formula we know, right? So what we do is that we introduce another variable. We introduce another variable which is often called t. So let 2x be equal to t. Then I would have something like this, sine of t with respect to x. I also cannot just solve this type of case. So while this is converted to t, we would like this x also to get converted to t. For this you have chain rule in differentiation. How do you convert d dx to d dt? You apply chain rule. Here you don't apply chain rule, but you do it like this. 2x is t. If left and right sides are equal, then their rates of change should also be equal, right? Their rates of change should also be equal. So I am going to differentiate both sides with respect to, let's say, t. With respect to, let's say, t. Now that's entirely my choice with whose respect I would like to differentiate both sides. If the sides are equal, I can differentiate them with respect to any variable. So I have chosen that to be t. d dt of 2x equal to d dt of t. Now here, this 2 will come out. 2 is a constant. Constant will come out. So you get this. What is d dt of t? d dt of t. One is correct. Okay. Now that means dx is dt by 2. dx is dt by 2. So we have integral sine t dx dt by 2. And suddenly the problem is solved. This 2 is a constant. You can take it outside the integral. And now, what is integral sine t with respect to t? That you know for sure. Sine of variable with respect to the same variable when integrated. That formula you know. What is that formula? Minus cos t. C will put at the end in the final answer. And in place of t, writing 2x. Now since we are doing indefinite integral, we must put some arbitrary constant at the very end at least. At the very end I have to put some arbitrary constant. So whenever you introduce third variable, in case of differentiation you apply chain rule, and in case of integration you go for just simple differentiation with respect to some variable of your choice. That variable could be either x or t. That really won't make any difference. And that's how you connect the two, dx to dt, change in x to change in t. So this method, if you have any question regarding this method, then let me know, or I will give you something for practice. Yes, I can tell you that why it is there. The reason is the same, that if I have to integrate anything, how can I be sure that the answer is this only? How can I be sure that answer will be this only? Because ddx of minus cos x is sin x, correct? But ddx of minus cos x plus some c is also the same. So how can I be so sure that answer must be this only? I mean this only. So it's always a good practice that you introduce some arbitrary constant. That's why the word arbitrary is used. That constant g in gravitation, Newton's that formula, that is not called arbitrary constant. It is not arbitrary. Arbitrary constant is some constant which can take any value. Here, this c is called arbitrary constant. I can see that private message about integral of sec x. Now, there are many results that we cannot discuss at this stage. For example, we discussed that differentiation of log x is so and so, but we did not discuss integration of log x, right? We did not discuss integration of log x. While we discussed differentiation of sec x, we did not discuss integration of sec x. There are too many examples. If you open any calculus textbook, integration part, you will come across many formulae which we don't discuss at this stage. So you will have to assume that many things you are going to learn over a period of time. At this stage, it would be inappropriate to discuss them. Any other question if you have, then just let me know. Okay. Now we talked a lot about indefinite integral. It is also called antiderivative. Whatever is the differentiation, just opposite of that is antiderivative, that is indefinite integral. Yes, with arbitrary constant. Just like differentiation has some geometrical visualization, slope of tangent, integration also has some geometrical visualization. Now I'm not talking about indefinite integral, Indefinite integral also has geometrical visualization, but what is more important for physics course is something else, and that is the geometrical visualization of definite integral. Geometrical visualization of definite integral. The first question is, what is definite integral? Whatever we discussed, just put some limits in that, lower limit to upper limit, and you get now an answer which is free from arbitrary constant. Now you get an answer which is free from arbitrary constant. Since arbitrary constant is gone, you are definite about your answer. Otherwise, when there was arbitrary constant, then you were just not definite about your answer. Arbitrary constant can take any constant value. So, in case of definite integral, you have two borderlines, lower limit and upper limit. Let me give you an example. Integrate x square with respect to x, if that is the question. It is a question of indefinite integration, and your answer would be x cubed by 3 plus c. Done. But if we say integrate x square between the two limits, one limit is maybe 2, other limit is maybe 5, then we are not done yet. After writing x cubed by 3 plus c, what we do is that we put the top value in place of x, 5 cubed by 3 plus c. Then we put the lower value in place of c, 2 cubed by 3 plus c. Then we put a minus sign in between the two. Clearly, putting minus sign will cancel c's, and you would get 5 cubed minus 2 cubed by 3. That's the net answer free from arbitrary constant. And note that c is gone. That's why it's definite. C will always cancel when you put two limits, upper and lower limits. This is the meaning of definite integral. It's the same thing what we discussed with two limits, upper and lower. So once you solve indefinite integral, you put the upper limit, you put the lower limit, and then you put minus sign in between the two, and you get your final answer. This is how you calculate definite integral. But what is the geometrical visualization of definite integral? Geometrical visualization of definite integral. Okay, before I discuss geometrical visualization, there is a private message about limits. Will the limits be given to us? No, limits will not be given to you always. In fact, in physics, mostly you will have to find limits on your own. In physics, most of the times, you may have to find limits on your own. You will be able to find limits looking at the particular situation. I will tell you how. So first, let's have a geometrical visualization and then understand how do we choose the limits. Now what is the geometrical visualization of integral a to b y dx? Plot y with respect to x. Mark point A on the x-axis, mark point B on the x-axis. this area which I am shading right now, this is exactly what is the geometrical meaning of integral a to b y dx. So it is nothing but this area. So while limits may not be given to you directly, you may be given the limits indirectly. For example, in VT graph, what does the area represent? In VT graph, what does the area represent? Distance, okay, let's not bother about distance or displacement. So you get the idea. So suppose the question asks you, what is the distance traveled by the particle between the second and 10th second? So question is not telling you integrate 2 to 10 type of thing, but it's telling you indirectly what should be the limits of integration. So if the question is saying 2 seconds to 10 seconds, then integration will be done between 2 to 10, right? So with respect to, or let me put it this way, in case of y, you have v, in case of x, you have t. You plot v versus t. Now that graph may change depending on case-to-case basis. But whatever time intervals you have, you will be able to find some area. That is the distance traveled. In case of speed time graph, it could be the distance traveled. So let me call it speed, let me call it time. And now you probably would have realized how important integration is, definite integration is. You deal with VT graph all the time. And while earlier you could handle simple situations like this situation, VT graph is a straight line. For that area, you don't need integration. If you are to find this area, which is a trapezium, you don't need integration for that. Trapezium you can handle. But what if VT graph is not a straight line? Now suddenly definite integral becomes so important. If it's not a straight line, then you can't handle it from basic mensuration. Like here. And integration can handle it. So integration y dx means plot y with respect to x. Mark the lower and upper limits. Choose the points corresponding to these limits. And close the area. And this is what you would get when you find this integral. And this area can represent some physical quantity. That's why it is so important in physics. This is not just mathematical mensuration area. It can represent some physical quantity. Like here, it could represent the distance traveled. Distance is just one example. There are several physical quantities which can be obtained by integration. So the question is, how do you know that those physical quantities which can be obtained by integration? Just from the definition. How do we define speed, for example? Speed. Speed is defined as dx by dt. Rate of change of s with respect to time. Rate of change of s with respect to time. This is how you define instantaneous speed. Speed at that very moment. So if you say speed is obtained by differentiating s, then from antiderivative concept or indefinite integral concept, s will be obtained by this. So it's so easy to tell if something will be obtained by integrating the other thing. So just like we say v is dx by dt, well, there can be other things. For example, a, acceleration can be dv by dt. So if acceleration is dv by dt, then what will be v? Integral of a dt. So whenever you see differentiation, you have integration. Now while we are discussing this in the context of physics, actually this concept can be used to find the actual areas. So if you have some complicated curve, say for example ellipse, you must have seen something like this, that's ellipse. Now you want to find the area of the ellipse. How will you do it? Integration can do it. Just follow the same approach. Y dx. And you can find the whole area for ellipse. So from physics perspective, when we calculate area, it tells us some physical quantity. But integration is also a mathematical thing. So in mathematics also we are able to do so many things. Finding areas of many complicated shapes, even volumes of complicated shapes can be found by integration. And many other things can be done by integration. But from physics perspective, you will be finding some physical quantity when you are integrating. Try to do this straightforward problem quickly. This is the definite integral problem. You will have to put the limits of integration once you have found your answer for indefinite integral. Well, the answer that I have is more than 180. More than 180. And by the way, looking at that message, I think you missed on 5 also. How would you integrate 5? 5 is 5 dx. Constant comes out of integral. 5 comes out, and integral of dx, integral of 1 means x to the power 0. So x to the power n plus 1 upon n plus 1. 5x. 5x you would get for just 5. And the final answer is 181.5. That's correct. If anybody would like this whole thing to be discussed on the board, then raise your hand. If you have a specific question, then put up that question. Okay, here we go. First we isolate various functions. As you isolate the functions, just retain the limits. Limits won't change. Taking 2 out, taking 3 out, taking 5 out, x cubed by 3, from 3 to 6, x square by 2, from 3 to 6. This is just a way of writing. After integrating, this is how you write the limits. Before integrating, this is how you write the limits. After integrating, you write them like this. Then right side integral I have already discussed. Putting 6, putting 3, putting minus sign in between. Putting 6, putting 3, minus sign in between. Putting 6, putting 3, minus sign in between. Just simplify this and let me know if you have any questions. Now try this one. Integral 0 to t a sin omega t dt, where a and omega are constants. You are coming close. Try to double check your working and perhaps you can get the accurate answer. Yes, I think I can see that accurate answer. A times 1 minus cos omega t in brackets whole divided by omega, that is the correct answer. If anybody would like this to be discussed on the board, then raise your hand. Okay, here we go. First we take the constant out. So A is out. 0 to t sine omega t dt. Now clearly this variable is omega t, that variable is t, not allowed to use the formula directly. So method of substitution, let omega t be some other variable u, that would make it sine u, but we would like dt to get converted to du also. So for that, let us differentiate both sides with respect to, let's say, t. Differentiating both sides with respect to t. Omega is a constant, comes out of derivative. d dt of t is 1. Now that means in place of dt, du by omega can be put. Now if we have changed variable from t to u, limits should also be changed. When we say omega t is u, when t is 0, how much will be u? When t is 0, how much will be u? That's correct. And when t is t, when t is t, how much will be u? Well, u is omega t. U is omega t. Yes, this is correct. Now this omega is a constant, comes out of the integral. This variable and that variable, they are same, so you can use the formula. Integral sign is minus cos. Now whether I write c here or not, it won't matter because there are limits that I am going to put, right? So it won't matter whether I write c there or not. I am not writing c there. 0 to omega t. In place of u, putting omega t. In place of u, putting 0. And between these two fellows, putting minus sign, closing. So minus cos omega t, minus of minus 1. So 1 minus cos omega t whole multiplied by a by omega. If you have any question in any of the steps here, just let me know. Yes, yes. Let me know your question. If you are using pointer, just change your pointer so that I know it's yours. You can change the pointer from the bottom. Yes, yes, yes. Fine. Okay. How did we get omega t there? That's because look at this step. Let me use this pointer arrow. In this step, the limits were 0 to t. These limits were on t. But the moment you converted the problem to u, these limits are going to change. It's not t, it's u. How to change the limits? Omega t is u. When t is 0, omega into 0 will be 0. That means u will also be 0. So this is 0, and when that is 0, u will be 0. This is not just copied from here. This 0 has been calculated separately from here. And when t is t, u will be omega t. So that omega t is written here from this. Any other question, let me know. Okay. So we stop now.